Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we're going to discuss in our video is partial fraction integration technique. In this video, we are going to take a look at integrals of rational expressions of polynomials. And once again, let's start this video out with an integral that we can already do so. We can contrast it with the integrals that we will be doing in this video. Let me take one example and explain you. This integral can be written as, if you assume this function as u equal to x square minus x minus 6, du will be 2x minus 1 dx. You can also refer the previous video on substitution. So if you do this integral, you'll be getting ln of x square minus x minus 6 plus c. If you back substitute the u, you'll be getting, so if the numerator is the derivative of the denominator or a constant multiple of the derivative of the denominator, doing this kind of integral is fairly simple. However, often the numerator is not the derivative of the denominator or a constant multiple. Am I right? For example, consider the following integral. In this case, the numerator is definitely not the derivative of the denominator, nor is it a constant multiple of the derivative of the denominator. Therefore, the simple substitution that we used above, the previous example, won't work. However, if we notice that the integrand can be broken up as follows. This can be broken up as 4 over x minus 3 minus 1 over x plus 2. If you factorize this, it will happen easily. So I'm going to just break this up. Then the integral is actually quite simple. If you split this integral, you'll be getting ln of x minus 3 times 4 minus ln of x plus 2. Finally, plus c. Hope you're clear with this example? Yes. This process of taking a rational expression and decomposing it into simpler rational expressions that we can add or subtract to get the original rational expressions is called the partial fraction decomposition. Many integrals involving rational expressions can be done if we first do partial fractions on the integrand. So let's do a quick review of partial fractions. We will start with the rational expression in the form. So here is the expression where both p of x and q of x are polynomials and the degree of p of x is smaller than the degree of the q of x. Recall that the degree of a polynomial is the largest exponent in the polynomial. Partial fractions can only be done if the degree of the numerator is strictly less than degree of the denominator. This is an important point to remember. So, once we have determined that partial fractions can be done, we factor the denominator as completely as possible. Then, for each factor in the denominator, we can use the table to determine the terms we pick up in the partial fraction decomposition. Let me show you the table. Here is the table for your glance. So please notice that the first and the third cases are really special cases of the second and fourth cases respectively. There are several methods for determining the coefficients for each term, and we will go over each of those in the following examples. Let's start the examples by doing the integral. Here is the first question. Here is the question. The first step is to factor the denominator as much as possible and get the form of the partial fraction decomposition. By doing this, it will give a over x minus 3. First, let me factorize the denominator. This can be written as a over x minus 3 plus b over x plus 2. So the next step is to actually add the right side back up. So let me write it on the board. Now let me add the right side. So it would become, it is just like fractional addition. Here this is a positive sign. Now we need to choose a and b so that the numerators of these two are equal for every x. To do this, we will need to see the numerators equal. So on the left side we have 3x plus 11. Hope you're clear so far? Note that in most problems we will go straight from the general form of the decomposition to this step and not bother with actually adding the terms back up. The only point to adding the terms is to get the numerator, and we can get that without actually writing down the results of the addition. So at this point we have one of the two ways to proceed. One way will always work but is often more work. The other, while it always won't work, is often quicker when it does work. In this case, both will work, and so we will be using the quicker way for this example. We will take a look at the other method in the later example. What we are going to do here is to notice that the numerators must be equal for any x that we would choose to use. In particular, the numerators must be equal for x is equal to -2 and x is equal to 3. Am I right? So let's plug these in and see what we get when x is equal to -2 and x is equal to 0. I have just replaced all x by -2. So I'll get 5 on the left side, a times 0. So a vanishes and b times -5. So 5 equal to -5b. If you divide both the sides by -5, you'll be getting b equal to -1. Same way, let's check when x is equal to 3. Just replace all x by 3. So 3 times 3 plus 11, that is 20. 3 plus 2 is 5, 5a, and this would turn into 0. So 20 equal to 5 times a. If you divide both the sides by 5, you'll be getting a equal to 4. Hope you're clear with this step? Okay. So, by carefully picking the x, we got the unknown constants to quickly drop out. Note that these are the values we claimed that that would be above. At this point, there really is not a whole lot to do other than the integral. All we are going to do is plug in these values for a and b and then continue integration. So finally you'll be getting 4 outside, and this would turn into ln of x minus 3 minus ln modulus of x plus 2 plus c. Recall that to do this integral, we first split it up into two integrals and then use the substitution. So here u equal to x minus 3 and v equal to x plus 2 on the integrals to get the final answer. Hope you're clear with this example. Before moving on to the next example, a couple of quick notes are in order here. First, many of the integrals in partial fraction problems comes down to the type of integral seen, I mean the table that is shown. Make sure that you can do those integrals. There is also another integral that often show up in these kinds of problems. So, we may as well give the formula for it here, since we are already on the subject. Okay, let me give you the formula. Here is the formula. It'll be an example or two before we use this, so don't forget about it. Now, let's work some more examples. I'm going to post next example question. Here is the next example. We won't be putting as much detail into the solution as we did this in the previous example, the same steps. The first thing is to factor the denominator and get the form of the partial fraction decomposition. So if you factorize the denominator, you'll be getting x. If you first take x outside and then do the factorization. So I'll get x times x plus 2 times 3x minus 2. So this can be written as a over x, b over x plus 2, c over 3x minus 2. The next step is to set the numerators equal. I mean this one and on the right side. If you need to actually add the right side together to get the numerator for that side, then you should do so. However, it will definitely make the problem quicker. You can do the addition in your head to get that. Let me show that step. Now I'm going to equate the numerators. Hope you're clear with this step. As with the previous example, it looks like we can just pick a few values of x and find the constants. So that let's do that. I'm going to assume x is equal to 0, x is equal to -2 and x is equal to 2 over 3. Only then these values will get cancelled and we can find the values for a, b and c separately. I'm going to assume these x values one by one and find the corresponding ABC values. When x is equal to 0, if you just plug in x is equal to 0 here, I'm getting a equal to -1. Second case, when x is equal to -2, I'm getting b equal to, these two gets cancelled out and this is equal to 1 over 2. When x is equal to 2 over 3, let us just plug in this value here. So I'm getting, on the left side I'm getting 40 over 9 and on the right side I'm getting 16 over 9. So if I simplify that, I'm getting 40 over 16 Yes, 5 over 2. C value is 5 over 2. Note that unlike the first example, most of the coefficients here are fractions. That is not unusual, so don't get excited about it when it happens. Now let's do the integral. Just plug in all the ABC values and apply the integral. Again, as noted, integrals that generate natural logarithms are very common in these problems. So make sure you can do them. Also, you were able to correctly do the last integral, right? The coefficient of 5 over 6 is correct. So make sure that you do the substitution required for the term properly. All you have to do is plug in these values and find the integral. So that's it for this video. We can do more examples in the next video. In case if you get any query, kindly let me know. See you in the next video. Have a great time ahead.